Okay, hello everyone. Let's go ahead and take a look at variance and standard deviation. Now in order to go ahead and do this, let's take a look at two different data sets. We have this data set here, 10, 20, 30, 40, 50, and another data set here, 28, 29, 30, 31, 32. So what we're going to do is we're going to calculate the variance and the standard deviation. Now how do we go about doing that? Now the first thing, of course, is that we have to calculate the mean. Remember in the previous lesson, we were saying that the variance and the standard deviation is based upon the mean. So we have to calculate the mean, and notice that the mean in both of these, for both of these data sets, is 30. So what we're going to do now is, being that that's the same, is we want to actually show how the variance and the standard deviation is going to say that these two data sets, even though they have the same mean, are different. And of course they're different because of their spread. And we'll show that numerically now. Now, how do we calculate sample variance? Okay, the variance is basically going to take we're going to take a look at the mean value minus subtract it from the values that we have, take all of those values and square it, add it all up, and divide by n. Now the standard deviation is just going to be the square root of the variance. So what we want to do first, of course, is calculate the variance. So let's do that. So we know for a fact that the mean here is going to be 30. So if I take 10 and minus 30, that's going to give me 20. Square that, it's going to give me 400. And I'm going to do that for every value that I have here. And notice that I come out with these values for the difference between the mean and the actual value itself, and squaring that value. So what I come out with then is this. If I add all of those values up, I come out with 1,000. Now what I'm going to do is I'm going to divide by the total number of values that I had, which in this case is 1, 2, 3, 4, 5. So if I go ahead and take the sample variance, it's going to be of the 5 terms squared. That is going to be equal to 1,000 divided by 5, which is 200, and that is the variance. Now if I want to go and talk about the standard deviation, I just take the square root of both sides, and the standard deviation of this particular data set is actually going to be 14.14. Okay, so what we want to do then is we want to go ahead and take a look at this side here, and if we go through the same process, notice that what we have is 41014. Add those up, we come up with a value of 10. And if we go ahead and divide by the total number of values that you have, which is 5, we come up with 2. So the variance is 2. And then if we take the square root of both sides, we come up with 1.1414. Now, let's just stop here and let's just see what those numbers actually represent. Now, notice that in this particular case here, the spread is much larger. In this case over here, the spread is much smaller. Of course, remember that both of those, the mean is going to be 30. So from the mean, how spread out are these values? These values are spread out very, very small. The spread is very small, which is going to be represented by this small value here of 2, as opposed to this larger value here of 200. This 1.414, or the standard deviation value, is also much smaller compared to this standard deviation value of 14.14. So that's going to give you a mathematical means by which we can go ahead and describe the spread. Now, if we just conceptualize what is the spread, notice this is something very similar to taking the average, right, or the mean. Really, that's something that you're calculating here, because we're taking the values of how far away those particular values are from the mean. We're taking that distance and then we're squaring it to make sure that it's a positive number, adding all of those distances, or the distance away from the mean, the square difference away from the mean, and then dividing it by the total number of values. You're coming out with basically the average square distance away from the mean. And that's what the variance is actually giving you. And then if we go ahead and take the square root of that, then we come out with what is called the standard deviation. Okay, so that's basically what's happening here with regards to sample variance and sample standard deviation as a means by which we can mathematically describe how spread out the information is from the mean. Okay, so what we want to do is we also want to extend that to one other thing here, is we want to extend that to the population variance. Now, how does the population and the variance, and say for example the sample variance, differ? Well, the only thing that differs here is that for the population variance, you have to divide by one number less. Okay? So in other words, in this case over here, we divided by 5. But in this case, if we wanted to calculate the population variance, we'd have to calculate it by dividing by 4. And so notice that what you should notice is that the sample standard deviation is actually less than the population standard deviation. And it's going to be the same for this case over here. Okay, now why is that the case? And remember, the relationship between the sample and the population is that the sample is actually just a representation of the population. So what that means then is, being that the sample is only a part of the population, we have to make sure to include a type of error in all of our calculations, because it's only looking at a sample, and in order to generalize over the population, we need to include some means by which we can incorporate that error, and we just incorporate it simply by looking at one value less than the sample variance. Okay, so in other words, the population standard deviation and the population variance is always going to be larger than the sample variance and the sample population. Okay, so hopefully that's clear there. Now what we're going to need to do, being that this was just looking at calculating the variance or the standard deviation based upon just a data set, we also want to take a look at what happens when we look at data presented in a different form.